rulers because we're going to do sketches of the graph. Some of you like to have real neat notes. Some of you don't care, so use it if you need to. Don't use it if you don't want to. Okay, so the definition of a multiplicity. A multiplicity is the number of times a factor occurs. So if we talk about, and you don't have to write this in your notes if you don't want to, this next part, but if I have 2 cubed, what does that mean? 2 times 2 times 2, right? So that means that 2, if that's your factor, that occurs 3 times, okay? Because the exponent tells you that. So we're going to use that same idea, but with polynomials. So if I have this example here, I don't know why I just put a g, but I'll just go with it. G of x equals x plus 2 squared and x minus 3, we'll do to the 5th. Okay. From yesterday or from before spring break, you should know or be able to tell me what the zeros are. So if I look at the first factor, which is x plus 2, that gives you a 0 of negative 2. If I look at my second factor, x minus 3, that gives you a 0 of 3. Okay. Now, the exponents are your multiplicities. So the 2 here and the 5 are your multiplicity. Which means that at my 0 of negative 2, that 0 occurs 2 times because the exponent is 2. At your 0, which is 3, it's going to occur 5 times because the exponent is 5. Okay? And there's a way to represent that graphically, and that's what we're going to do today. Okay? Now, you have 2 different types of multiplicities. As we demonstrated in the fact, you have 2, which is an even number, and you have 5, which is an odd number. Okay? So if we have an even multiplicity, when we graph, the graph will hit the x-axis at the 0 and bounce back. The key word there being hit. It's going to come in and hit that 0, and then it's going to bounce back where it came from. So for instance, if I squeeze a little sketch in here, if this is my 0 right here, okay, and I'm coming into my 0, I just hit it, and if it is an even multiplicity, then it's going to bounce back. So that means it's going to go like this, and it's going to look like a U or a parabola, whatever you think that looks like. Okay? So if I have an even exponent, it always at that 0 is going to look like that U or that parabola shape. Okay? Your multiplicity and odd multiplicity. So your graph will cross the x-axis at the 0. keyword there, cross. Today's notes, moving into Thursday's notes, moving into next week's notes, are all going to start putting all of the pieces that we have been doing together. Okay? Now, we've done odd multiplicities before. Before spring break, every one of them that we graphed had an exponent of 1. 1's an odd number. Right? So we already did these. The only new part is really the even one. So what's going to happen here? If this is my 0, it just means it's going to go straight through. It could go straight through going in a positive direction. It could go straight through going in a negative direction. Okay? That's the new piece that we're doing today. Okay. So we're going to do 5 examples. So you should be able to put at least one below this here in your notes, and then you could put 4 other ones on the other side, something to that effect. Okay, so number 1. Okay, so here's the parts that we did yesterday in the review. You have to tell me what the degree is. What's the degree of this function? Cubic, it's 3. Your leading coefficient. So all I'm asking, is it positive or negative? It's positive. I'm going to put EB for M behavior, because I want to shorten it. I don't want to write it out. And you can look at your table. So 3 is odd, and it's positive. Odd positive means that we are down up. So your N behavior is down, up. And the other thing that we did yesterday was, could you tell me your 0? So what is your 0? I tried you. There you go. What's your 0 of this function? Negative 4. So x equals negative 4. Actually, because then you can kind of, you'll miss the first example, but you can get caught up then with the rest of them. Okay. Okay, so we're going to put a sketch here. So I'm going to use my straight edge, and I'm going to draw my x and y axis. And not crooked like that. There we go. Okay, so I'm going to put my 0 on here. So 1, 2, 3, 4. Right there. It's at negative 4. I'll put my 0 there. I'm going to put my arrow, which tells me that I'm down on the left and up on the right. And now I have to look at my 0, and it has a multiplicity of 3. So if you remember, and I just gave my notes away, but if you look back up to where it says odd, it said that you cross it. So I know that I'm going to cross through this. So when I take my down arrow, I'm going to go through negative 4 and then connect over to my other arrow. It shouldn't be a straight line because we know this is not linear, it's cubic. Okay? It's fine if you put a line there, but it shouldn't really be, you know, it's got a little curve here, something like that, a curve here. just a slight, you know. Basically, when I look at grading something like this, tomorrow when you're doing your work, do you have your arrows correctly? Do you have your 0 correctly? And at this 0, did you go through it like you were supposed to? Okay? It's the type of thing I'll be looking for. Okay, question number 2. Okay, so it's the same questions. Each time we do notes this week, we'll just add to the questions that we are doing. So, degree. What is the degree of this function? Nope. Not 2, not 3. Quartic, it's 4 because this is 1 plus 3, which is 4. If you maybe remember back from yesterday you had a problem that was, I don't have the exact numbers, I'm just kind of making something up. But to find the degree of that, you did 1 plus 1 plus 1 to get 3. So today you're going to do 1 plus 3 to get 4. Is the leading coefficient positive or negative? It's positive. So what is your end behavior if we have degree 4 and positive? Up, up. What are your zeros? So just the x by itself is going to give you what 0? 0. And the negative 1 would give you a 0 of positive 1. Okay, so I'm going to have a dot at 0, and I'm going to space my other one out a little bit farther, and a dot at 1. So there's your 2 zeros marked on your graph. We know both of our arrows have to be up. So up and up. If I look at my exponents, they are both odd numbers. So that means that when I go here at 0, I have to go through both of my zeros. So when I start with my arrow on my left, I'm going to go through 0, curve, go through 1, and end up going back up. So odd, they're going to go right through. They're going to cross over the x-axis and then go on to the next one. So let's do one that has an even in it. So y equals, let's do x plus 2 squared and x minus 1. Yeah, let's do that. Okay, what's your degree? 2 and 1 gives you 3. Degree 3. Positive or negative? Positive. So if we're degree 3 and we're positive, what's the end behavior? Down, up. And your zeros. So the first factor, x plus 2, is going to give you a 0 of negative 2. And the second factor is x minus 1 is going to give you a factor of 1. Any questions on those? Kind of weird with only half a class here. Okay, so I'm going to put a 0 at -2 and a 0 at 1. And we have an arrow going down on the left and up on the right. Okay, so we have to look at our zeros. At -2, is that even or odd multiplicity? It's even. So that means that when I come in from my down arrow, when I come in here and touch at -2, I'm not going through it, I'm curving and going to come back down. It's even. Even look like parabolas. Then I'm going to curve again, and when I touch at 1, am I going to go through it, or am I going to curve back down? Well, I have to look. What's the exponent? It's a 1, which is odd, so that means I'm crossing straight through and ending up going up. You can only cross your x-axis where you put your zeros in. You can't cross multiple times. Okay, so you guys try this one. Okay, so what is the degree of this problem? What's 1 plus 2? 3. Is it positive or negative? Negative. So degree 3 and negative. What's our end behavior? Degree 3 and negative. Up, down. Okay, so your zeros. -3 and 1. Okay, so at -3, I'm going to put a point, and at 1, I'm going to put a point. And we know that our arrows are up and down. Okay. At -3, our exponent is 1. So I'm going to cross straight through. So I'm going to take my up arrow, and I'm going to go straight through -3. Then I'm going to come over to 1, so I'm going to curve over to 1. And do I go through at 1, or do I curve back down? You curve back down because it's even, and I end up at my down arrow. Those of you that just came in, we've got one more problem left, so you might just want to follow along or just listen, okay? You can do it however you want. Okay. So number 5, y equals negative x plus 1 squared, x minus 1, and x minus 3. Actually, those of you that just came in, you probably can answer all the parts but the graphing, because this is what we did yesterday in our review. Okay, what's the degree of this problem? 4. 2 plus 1 plus 1. 4. What's the leading coefficient, positive or negative? Negative. So the end behavior is down, down. Okay, your zeros. The first one would be -1, then, and then 3. Where'd mine? Okay, so we have a point at -1, a point at 1, and a point at 3. Okay. We know both of our arrows have to start going down and end going down. Okay, so our first zero is -1, which has an exponent of a 2. So am I going to go through, or am I going to curve back down? Curve back down. So I'm going to go up to -1. I'm going to curve back down. Now I got to look at the next one. At my 0 of 1, it has an exponent of 1. So that's odd. So does that curve or go through? It goes through. So I'm going to curve and I'm going to go through. And then at positive 3, it has an exponent of 1. So I'm going to curve back, go through, and end down. So it looks like you have like 2 humps of a camel or something. I don't know. And that's